Well, hello. Today we're going to be discussing something known as the remainder theorem when we are dividing a polynomial by a linear expression. So what you see here on this screen right here, all of this is what we would classify as the remainder theorem. So we have some function f that is a polynomial function, and it's going to be divided by a linear factor. Well, it turns out that the remainder that I would receive by dividing by the solution of that factor would also produce the same number if we substituted it into the polynomial itself and evaluated it. Now, it's useful as a student to understand what that is, because generally in algebra there is always a way to check what you're doing. Well, this absolutely provides a way to be able to check what you are doing, to check your answers. Did we do it correctly? So what we see here is a fourth degree polynomial, 3x to the fourth. That's why we call it a fourth degree polynomial, because the largest exponent is a 4. And we're going to divide that polynomial with a linear factor of x minus 2. So using our rules for synthetic division, we would take that linear factor, set it equal to 0, and solve for x. And in doing so, we would get a positive 2. And now we're going to use that to use our synthetic division properties to divide the polynomial. So as we did before, we're going to take the coefficients. So here I have a 3. The x cubed term is missing, so I'm going to just write it here as a reminder to add it. Okay, negative 2, positive 5, and negative 4. So we take those values, positive 3, the 0 for the x cubed term, the negative 2, positive 5, and negative 4, and now we have our division problem set up for us. So as we did in previous lessons, take the first number and just drop it straight down. So we have a 3. Multiply the divisor, the 2, with 3, and we get a 6, and we put that underneath the next column. Add those two numbers together, and we get a 6, and just go through the same process that we have been doing for synthetic division. 2 times 6 is 12. Add those, and I get a 10. 2 times 10 is 20. Add those, and I get 25. 2 times 25 is 50. Add those together, and I get a 46. And that's my remainder. So what the remainder theorem says, okay, this 2 that we got, the solution to the linear factor, that number should produce the 46 that we got as a remainder when we substitute it into the polynomial expression. So using yellow on this really isn't going to be helpful, so let's pick a different color that'll show up better. So let's take the 2. So I'm going to say f of 2. And I'm not sure I like the green either. Let me pick something a little darker. Let me get rid of that. Pick something a little darker, maybe it'll show up better. Let's just do black. So here we're going to say f of 2, and anywhere I have that 2, I'm going to substitute it into the polynomial expression. So 3 times 2 to the 4th minus 2 times 2 squared plus 5 times 2 minus 4. And what we're going to see is when I evaluate everything, we should wind up with the 46, the same number that we had as a remainder. So 3 times 2 to the 4th power, well, 2 to the 4th power is 16. 16 times 3 is 48. Negative 2 times 2 squared, well, that's basically like saying 2 cubed, so that's going to give me minus 8. 5 times 2 is a 10 minus 4. Okay, so let's see, we got these two together, that'll give me a 40. These two together will give me a positive 6, and 40 plus 6 is 46. So that is what the remainder theorem says. It's again just telling you is that if we take the solution to the linear factor that we do our division with, and we substitute that into the original polynomial, it should match whatever the remainder is, and that will at least as a student is concerned, identify did you do your synthetic division properly. So here we have a third degree polynomial, and what they're doing is they've provided us in part A the solution to a linear factor, which would have originally have been, well, x, I guess we should probably say p, but we'll just say x plus 2, and this one would have been x minus 3, because if I solve both of those, I get the positive 3 here and the negative 2. So what we want to do first is do our division. So the solution that we have to our linear factor would be a negative 2, so I'm going to divide with a negative 2 and take the coefficients. So 3, 2, 1, we're not missing any exponents, so I'm going to say 1, 4, negative 8, and negative 15, and let's go through our division. Bring down the 1, multiply, negative 2, add those and I get 2, multiply and I get negative 4, add those together and I get negative 12, multiply those together and I get a positive 24, add those together and I get 9. So my remainder is a 9. Now let's check it using the remainder theorem. If I say p of 2 and substitute negative 2, if I substitute that into the expression, I'm going to get negative 2 cubed plus 4 times negative 2 squared minus 8 times negative 2 minus 15. Negative 2 cubed is negative 8. 4 times negative 2 squared is going to be a 16. Negative 8 times negative 2 is another 16 rather, and a minus 15. So these two together give me 8. These two together give me 1. So 8 plus 1 checks out. So let's do the second one. See how, again, this is really just kind of providing us a little bit more practice with our synthetic division and the opportunity to be able to check our work now. So now we're going to do the division with the 3. So the 1, the 4, negative 8, negative 15, that doesn't change from the original problem. Bring down the 1, multiply, add, multiply, add, multiply, and add, and I get a remainder of 24. So to check using the remainder theorem, did we do our division properly? I'm going to say p of 3 is equal to 3 cubed plus 4 times 3 squared minus 8 times 3 minus 15. Well, 3 cubed is 27. 4 times 9 is going to give me a 36 minus 24 minus 15. Okay, add these two together here and I get a 63. Add these two together here and I get a negative 39. And 63 minus 39 is 24. So those checked out. So last one that we're going to take a look at, very similar in nature to the last example. All we're going to do is do the division and then check it by substituting the solution of the linear factor into the problem. So this first one would have been x plus 2, and this one would have been x minus 2. So let's look and see what we get. Do our division. So let's start with the negative 2. So looking at our exponents, we have 4, 3. We're missing a 2, so I'm going to say 0x squared. We have the 1 in that, so we have to add 1 0 placeholder in. So the exponents, or I'm sorry, the coefficients would be 1, positive 3, 0, negative 2, and negative 4. So let's do our division. Bring down the 1, multiply, and I get negative 2, add, and I get 1, multiply, add, multiply, add, multiply again, and add, and I have a remainder of negative 8. So let's check with our remainder theorem. Substitute that number in. So if I say p of negative 2, we're going to say negative 2 to the fourth power plus 3 times negative 2 cubed minus 2 times negative 2 minus 4. Here we're going to say negative 2 to the fourth power is going to give us a 16. 3 times 8 negative essentially is going to be negative 24. Negative 2 times negative 2 is a positive 4, and the minus 4 at the end. And we can just cross those guys out because we can see that they cancel. So 16 minus 24 is a negative 8, so that worked out. And so our last example that we're going to take a look at, p of 2, we're going to do our same division, but in this case with a 2 instead of a negative 2. So 1, 3, 0, negative 2, negative 4. And let's go through the spin cycle here. So bring down the 1, multiply, and I get 2, add, and I get 5, multiply it for 10, add for 10, multiply for 20, add for 18, multiply for 36, and add to get 32 as a remainder. Okay, so now we're going to check p of negative 2, I'm sorry, not negative 2, p of positive 2, and we're going to say 2 to the fourth plus 3 times 2 cubed minus 2 times 2 minus 4. And check it out and see what we get. So 2 to the fourth power is 16. 3 times 8 essentially is going to be 24. And minus 4 and minus 4. So add those two together, and that's going to give me a 40. These two together give me minus 8, and 40 minus 8 is a, oops, not negative, but a 32. So they do indeed check out. So this is just us being able to verify that we're doing our synthetic division properly. And from there, it's just a matter of checking it by substituting the answer of the linear factor back into the problem and see does it match our remainder. But that's going to be it for this lesson. If you have any questions, please make sure you get them copied down and bring them to me in class. Otherwise, I just look forward to seeing you soon and see you in class. Take care.